Let's finish our look at adding and subtracting radicals by looking at how factoring can help us simplify radical expressions. In this example, we obviously have two square roots, so that index check is fine, but we're checking the radicands and seeing that they're not the same. In situations like this, where you have a binomial inside of the radical, you should try to rewrite the expression as much as you can as a product of its factors. Once you switch it to a product of its factors, it makes it, one, a lot easier to take square roots, cube roots, fourth roots, potentially, and two, it makes it a lot easier to look for those commonalities between the two expressions. So this is a really basic example of that concept, and then we'll look at a slightly more challenging one. Obviously, there's nothing to rewrite for the second radical. This is just the square root of x minus 7. But for the first one, we can imagine rewriting 9x minus 63 as 9 times x minus 7. So obviously now we're getting somewhere. We see this x minus 7 that matches the x minus 7 from the second radical. We engage our rules from the previous lesson, which said that we're allowed to split a radical as needed based off of multiplication. So we had two things, in this case a binomial and a constant, 9 and x minus 7, that were being multiplied together. We can split that multiplication into two separate radicals in the hopes of getting to match the second one. Root 9 is really just 3. So this is 3 root x minus 7 plus root x minus 7. So here I have 3 root x minus 7s. Here I have 1 root x minus 7. So altogether I'm going to have 4 root x minus 7. And that comes from an understanding of the greatest common factor up here. And it comes from our understanding of our ability to split a radical off of its multiplication. This example will be engaged similarly. We want to check for the things that we always know to check for. So these are both two-term binomials. So we check for difference of squares. Obviously, there's no subtraction, so it's not difference of squares. We check for sum of cubes. I see a couple cubes floating around, but nothing that I'm going to be able to factor with any kind of consistency using the same format that we saw previously. But I really always want to make sure I check for that greatest common factor. And in this case, my greatest common factor is what's going to open the door to being able to simplify these expressions. So looking at the first one, my greatest common factor for the inside is going to be 16x squared, leaving me behind an x plus 4. And then the second one, looking inside of there, my greatest common factor is going to be 25x squared. Excuse me, this was supposed to be 100. That makes it a little bit easier. So 25x squared, and that makes that x plus 4. If I had left that as a 10, we weren't going to be able to get the radicands to match. And then our step would just be factoring the greatest common factor for the sake of doing it and then not being able to get them to match. But if this is 100, and that's my mistake, if that's 100, then that's able to be factored as a 4. So similar to the last example, you can kind of see where this is going. The fact that I'm left over with an x plus 4 tells me that that's probably going to be the part that I'm interested in as my radical. So let's split these and see what we can do in terms of leaving behind that separate x plus 4 as the thing we're going to combine off of. Fortunately for us, both of these greatest common factors that popped out are both perfect squares that we can take the square root of. This one's perfect square is 4x. This one's perfect square is 5x. And then combining them together, I've got 9x root x plus 4, which all stemmed out of our ability to recognize the greatest common factor in a binomial. Resist the temptation to just not engage those skills that we've used before. If these radical symbols were not here, and this question just looked like this, you would think about combining like terms. Can't do that. If we're doing it with the radicals, we want to make sure that the radicands are the same. So you cannot jump and dissolve all of the skills that we've already established. If we have established rules for radicals that say I can split, then continue to split, but make sure it's written as a multiplication first. If we have established rules that say the radicands have to be the same, make sure they're the same. I was able to add down here because the common factor was the root x plus 4. That was the thing that they had in common. So really, there's this skipped step of 4x plus 5x times root x plus 4, like we saw in some of the previous examples. But since I could add those together, we can jump right to the 9x. So don't skip out on all of these rules that we've already established. We've established them for a reason, mathematically sound reasoning. But we're not going to abandon them just because an example doesn't fit our initial perception of what these adding and subtracting questions are supposed to look like.